This is Thermochemistry Packet Worksheet 5, where we introduce the idea of specific heat. This is the first part of Worksheet 5. There's going to be a separate video for the second part of Worksheet 5. So when we talk about heat, we need to first establish the units that we use to discuss heat. So if you take a look at your notes here, heat energy is measured either in joules or in calories. So scientifically, we use the term joules more often. It's the standard unit for energy, but in our daily life, we talk about calories also, generally in relationship to food. And when we talk about calories, we're really discussing the amount of energy stored in the food. So it is sort of an important relationship to know that 1 calorie is equal to 4.184 joules. That will be provided on tests. You don't need to memorize it, but you'll use that information a fair amount in these calculations. Also, when we're talking about larger amounts of energy, we talk about either kilojoules, abbreviated K, capital J, or kilocalories, kcals. And these are just 1,000 joules or 1,000 calories. Much like a kilometer is 1,000 meters. That prefix kilo means 1,000. Another important idea here is the idea of specific heat, which is, after all, the title of this worksheet. So the idea here is that different substances or materials differ in the amount of heat that it takes to increase their temperature. And we kind of know this just thinking about common sense, right? Most of you could tell me that if you put metal, like a frying pan, on a stovetop over a flame, it's going to heat up really quickly, right? But if you have water in a pan on the stove, the water is going to take a lot longer to heat up than the metal pan. So this is because metal and water have different specific heats. Okay, the amount of heat required to raise the temperature of the substance. So since metal heats up without a whole lot of difficulty, a whole lot of trouble, it has a low specific heat. But since water requires a lot of energy to heat it up, a lot more work to get it warmed, it has a high specific heat. So that's what is being discussed right here in your notes. And you need to know the units for this so-called specific heat, which is joules per gram degrees Celsius. So we could actually write that as a fraction with joules on top, and then both grams and degrees Celsius on the bottom. And the symbol that we use for specific heat is sort of a strange one. It's a C with a little P as a subscript. All right, so if we look at the calculations you're going to do, right, you guys are going to answer from this little reading that we just sort of went through. You're going to answer questions 1 through 6, but what I really want to talk about in this video are the calculations that you're going to be doing. So when we're doing just these basic sort of heat energy problems, we're going to use the formula given right here, which you don't need to memorize. It will be provided, that heat is equal to the mass of the sample times the specific heat, right, how easily or difficultly it will heat up, times the change in the temperature. So what I'm showing here below the equation is that mass is always measured in grams. Specific heat is measured in joules per gram degree Celsius, like we just discussed above. And then change in temperature, the units for temperature are Celsius, but change in temperature means you have to take the final temperature, the ending temperature, minus the initial temperature. And actually, in these equations, it's pretty easy because we're always going to set it up so we have the bigger temperature value minus the smaller temperature value. So this change in temperature value here should always be a positive number. All right, so if you look at example 1, this is a little story problem that we have to pull information out of and plug into our equation. Right? It wants to know the number of joules. Oh, heat is always measured in joules. So when it asks for the number of joules, you're really solving for heat in the equation. Okay, so it wants to know the number of joules. Right, that's what we're trying to solve for. That's supposed to be a question mark, sorry. That it's going to take to warm 100 grams of water, so that's our mass of the sample, from 25 degrees Celsius to 80 degrees Celsius. So that's our change in temperature right there. So we're just going to plug these numbers into this equation above. We want to know the number of joules, right? In other words, the heat. We put the 100 grams in. We multiply by the specific heat of water, because this problem is discussing water, right? Now, where did we get that specific heat of water? Well, that's a constant. We can always count on the specific heat of water being 4.184 joules per gram degree Celsius. Now, if they were talking about heat and specific heat in calories, you'd have to use this 1 calorie per gram degree Celsius. That's going to be a lot less common in these problems. So generally, you're going to be using the 4.184 number. So I put that in, and then I'm going to subtract my 80 degrees Celsius minus my 25 degrees Celsius, always making sure that I subtract the bigger minus the smaller number. So this should always give me a positive number. All right. Now, order of operations is important. That can throw you off, right? The very first thing that you need to do here, before you do your multiplication, which you'll get to eventually, you need to do your subtraction. So the very first thing I'm going to do is figure out that 80 minus 25 is 55. Now I can go ahead and multiply my mass of 100 times my specific heat of water, 4.184, times my change in temperature. And I get 23,012 joules, or in scientific notation, which you could put it into, is 2.3 times 10 to the 4th joules. Right? And I say joules are needed, so we're going to be adding the heat in this case because the problem said they're needed. We'll look at the next example where the heat is being released, given off, right? So if heat is being added, this is an endothermic reaction. In example 2, they're going to tell us that heat is being released. So if heat is being given off into the environment, we're talking about an exothermic reaction. And so in our answer, we'll note that heat was released. All right, so we will move on to example 2 here. This one again wants us to calculate the number of joules, right? So joules is measuring heat. We want to solve for heat that are going to be released when 72.5 grams of water. So there's our mass, and again we're talking about water, so we know our specific heat is going to be 4.184. And our change in temperature is going to be, we're going from 95 degrees Celsius to 28 degrees Celsius. So we just plug into our equation, right? We want to solve for the number of joules, in other words the heat. We put in our mass. We put in our specific heat of water, that's always going to be 4.184. And then we plug in our change in temperature, our bigger number minus our smaller number. For order of operations to be correct, get the right answer, I got to do this subtraction first. So 95 minus 28 gives me 67. I still have my mass and my specific heat of water, and then I just multiply those three numbers together, and I get 20,323.78, or I could, if I wanted, put in scientific notation, right? 2.03 times 10 to the 4th joules released. How do I know released? Well, because the problem told me, and that's just indicating that we're giving off heat as a product. We have an exothermic reaction. So when you get to class, you will continue practicing some of these problems on your own.